In this project, my colleagues Rekha Goswami and Grace Colleen studied the effects of BPA on Daphnia magna, which is a species of water fleas. And so the background on this project is that BPA is a very common toxin in microplastics, and it can be very harmful to ecosystems, particularly wetlands or any lakes or rivers or any aquatic environment. And the concern for BPA is that an increase in plastic pollution rates will lead to large-scale effects of ecosystems down the food chain as a result of harming organisms at the very bottom of the food chain, such as Daphnia magna, which are eaten by fish and other important organisms in aquatic environments. So doing this experiment, we set up 12 beakers. We had a control beaker, and then each category had 3 beakers within it. So we had 3 control beakers. We had 2 beakers that had a concentration of 2,000 micrograms per liter of BPA. We had a beaker with 4,000 and a beaker group with 6,000 micrograms per liter. And this increase in concentration was to see at what level it would be harmful to Daphnia reproductive rates. And so with BPA, BPA is an estrogen mimicker, and as you can see from the diagram in the introduction, BPA has a very similar structure to the steroid estrogen. So a way in which that we can reduce the effects of BPA is by using single-use plastics and avoiding those in favor of multi-use or reusable plastics. To start our experiment, we put 10 Daphnia in each beaker, and after a week, we went back and counted the number of Daphnia in each beaker by using a pipette. Daphnia magna are a very important model organism because their reproductive rates are about once a week as when they reproduce. So after 2 weeks, we ran into a problem of having far too many Daphnia in the beaker. And so if we had continued the experiment, our counts and measurements would have been far too inaccurate, and we would have reached the capacity for the organism to live in that container. So we stopped our experiment after just 2 weeks. But this was all the data we needed to perform a very important stats test. And we did an ANOVA test, testing the difference in groups between the control and the different levels of BPA. And what we found is once you hit a certain threshold, there really isn't a statistical difference in the effects of BPA on Daphnia reproductive rates. And so it's clear through our data with a p-value of 0.0172 that our data shows that BPA had a statistical significant effect on the reproductive rates of Daphnia. And so more testing would be needed to be able to see what exactly that threshold is of significance and be able to test and see what the effects of even less BPA on an aquatic environment would be. So our conclusion and discussion leads us to the push and encouragement of people to recycle and use multi-use plastics such as Tupperwares and reusable water bottles rather than simply single-use plastics that end up in a landfill because rain and rivers can very quickly lead to that ending up in important water reservoirs. Manufacturers are also making a move to make BPA-free plastics, which is another step in eliminating this problem in our aquatic ecosystems. This project was helped through the assistance of Cameron Smith, our TA, as well as Dr. Harville, our research professor. Thank you to the two of them and their ability to help us with both funding and knowledge.